Hi students. So I believe that our class is fully online now. I wish that we will have a good semester together. Me teaching you behind the camera and you learning behind the screen. Please do contact me via Teams message or email. Alright, if you have any issues or any problems that maybe arises during these trial times. Alright, so without further ado, I would like to welcome you to my first weeks of class and lecture called Week 1 Intro, Unit and Dimension. So let me take you to Times page. Hi guys, so what you are looking at is our Times page, Air Conditioning and Refrigeration Engineering, which I have introduced to you guys in my introduction video. So maybe you can just scroll down straight ahead until lecture notes section, and you are going to tap or click in whatever devices that you have right now on our first lecture note, which is HVAC or HVAC Week 1 Intro, Unit and Dimension. So if you click on that, it will bring you to a PDF file of the PowerPoint slide that I'm using throughout this lecture series. Okay, you can scroll it like that. Alright, so I will show you my PowerPoint. Okay, so please refer to the notes that you have from Times, yeah? Okay. Alright, welcome to my class. As I have there, the title of my lecture is Lecture 1, Introduction, Unit and Dimension, as you can see on the lower left section of my slide there. Alright, and this is about me. My name is Hardy Hidayat. Call me Dr. Hardy or Mr. Hardy if you like. My telephone extension is right there, 5263, whereby you can find it when you reach my office at C9 or Block C, Level 9. Right, since we don't have any physical classes, maybe you can give me your message to my email, hardy.hidayat@tls.edu.my, or leave me a message at Times. Yeah, you can just Times message me. I have the app with me so we can contact with one another. All right. Okay, so the next slide tells you the attend class, focus and appreciate feedback. So this is basically when we are having classes physically, but since we are not, then maybe I have some changes. For example, let me bring down my pen there. For example, this one, attendance will be done using Google Form. That is quite hard to do because we don't have any physical classes, and maybe the attendance that you guys will be having is at the end of every week you will have your tutorial, right? And one question will be left unanswered, right? We will discuss and answer all the lecture questions, lecture and tutorial question. Maybe one question will not be answered and you guys have to do it. Quite simple, and then submit it on Google Drive link that I will give later, and that will be your attendance. Whoever submit the short tutorial assignment, you will be attending my class. Okay, so let's go into our first topic. So this is our lectures. I have a few subsection there, right? So you have introduction, HVAC and introduction, and 3 more there you can see. Okay, so let's go and see it one by one. Let's go to the first part, introduction. Now, the course topics that we have in this semester are 8 altogether. Some of it have 2 weeks, some of it have 1 week, as you can see here, 1 and 2 weeks. That means some of them are going to be separated into few weeks. So it's a long lecture. I cut it part 1 and part 2. For example, number 2 there, air conditioning systems, we have part 1 and part 2. If you can refer back to my Times page, let me see if I can bring my Times. Alright, times page. You can see here some of the class are yes, have part 1 and part 2, okay, throughout the weeks. Okay, let's go back to our lecture. Alright, so we have 3 learning outcomes. You can refer this to the scheme of work as well. So we have number 1, explain the principles and application of air conditioning and refrigeration system. And here, our Bloom verb is explained. And therefore, this is usually for low-level question. I believe you guys know already what we mean by low-level questions. It means that the exam question or test or assignment will be based on these Bloom's level. So LO1 will cover the low level. Number 2, evaluate air conditioning systems based on cooling load calculation, ASHRAE tables and psychrometric charts. And this is mid-level questions. And the last one, select methods to control humidity, air contaminants and air distribution. This one will be high level. Right, so our questions, exams and tests will be based on these learning outcomes. Alright, next page. Assessments. We have 4 assessments. Number 1, we have tests. Number 2, we have assignment 1. Number 3, we have assignment 2. And we have final exams. Now, this is the first suggestion. At 15% for test 1, 15% for assignment 1, and 20% assignment 2, and 50% for final exam. I would like to remind you that this percentage will change because our university has new Taylor's Curriculum Framework 1 and 2. So in our TCF1 or Taylor's Curriculum Framework 1, it is required that the final exam to be reduced to 30%. So I will update this to you guys along our class, our lecture series about the distribution. Yeah. Also the week assessment, as you can see here. Test 1 is week 7, assignment 2 at week number 4, assignment 2 is at week number, assignment 1 is week number 4, assignment 2 is week number 9. This also will be changed and it will be informed to you guys as soon as we have our class going on. Alright, this is trial times, man. Okay, you will have these objectives. The first one, you will learn about the history of air conditioning and refrigeration. You will also learn units and dimension in HVAC&R and the fundamental physical concept that we will going to use in this lecture series. So let's go to the next part. What is HVAC&R? So usually what we call is HVAC, heating, ventilating and air conditioning, and also refrigeration. Right? So these term refers to the aircon that we use. The one that you have in your room, if you have aircon in your room there, it's called split aircon. But if you have a centralized system like our Taylor's University, it has centralized system, then it will have something on the ceiling. Right, and of course refrigeration refers to the refrigerator that you have in your kitchen or the one that we have in our in stores, maybe in supermarkets where you store meats and stuff. Okay, HVAC&R is the 10th most wanted engineering occupation, as it is the most, I would say, the most sought after section of aircon, maybe after oil and gas, because the world is getting hotter, and while we're adding heat more to the environment, we need to cool down our houses at least. All right. Right, let's go next page. Air conditioning system responsible for around 40% of energy consumption and living cost. I believe houses nowadays, almost every house, it doesn't matter if you go for the um, high and beautiful, high end and beautiful houses, towards the lowest section or lowest spectrum of income, most people at least will have an aircon in their room. Alright, so 90% of our living time, especially in Malaysia, because of the equator, we live in the equator, it's quite hot. We tend to spend our time indoors. So the studies of air conditioning and refrigeration, especially HVAC or aircon, is very important because as we stay indoor, we are circulating the air that we use. Though we are cooling it down, it might not be as healthy as it's supposed to be. So HVAC systems are becoming a central part of every buildings, small houses, big building, campuses, and maybe government offices and also industries. Right, so this brings cost and also profit. So the study of aircon is very sought after one of these days, yeah. Alright, so maybe I can give you a short intro that this is survey is in 2018 about HVAC job scopes. How much does it pay throughout the year? For example, the HVAC supervisors, you can earn around $88,000, depending where you work, of course, right? But payment or salary based on HVAC sector is quite high. All right, the concerns that we have in our HVAC system is three of them, other than cooling down and the efficiency of the air conditioning. So the first one is indoor air quality. Usually when we stay indoors, we tend to breathe the same air, and if you sit there in your room 8 hours a day or maybe throughout the whole day, for example where we are staying indoor in these trial times, then it might not be as healthy as you think. Number two, greenhouse gas emission. And of course, air conditioning is not that efficient for our nature. It's not that good. Not just that it releases harmful gases, it also uses high amount of energy. As you know that to bring out heat, usually and naturally, heat move from the high temperature place to the low temperature place. But to bring heat from a low temperature place to outside the room, you need high amount of energy to go against thermodynamics law of number 2. And the third one is energy conservation. Of course, we try to use the least amount of energy to give us highest comfort that we can. There are a lot of technologies that we have nowadays, such as inverters and so on and so forth. All right. The history you can read there on slides. I'm going to skip that. And also the big concept. The big concept is, you can see here, it's about temperature, cleanliness, humidity, and distribution. Distribution means how do you distribute cold air throughout the places. To distribute this, you have learned this in thermodynamics class, which is the basic components of a vapor compression refrigeration system. So you can see there on my slide there, you have a typical refrigeration cycle or typical HVAC cycle. You have your ambient air coming into and through the condenser. As it cools down the condenser, the refrigerator goes into the expansion valve and then go to the evaporator. And evaporator, you bring in hot air from the room and to outside. So you have learned this condenser, compressor, evaporator. What do they do in your thermodynamics class? So maybe you can use this YouTube video. So you can click there on the vapor compression cycle and you can see that how does the 4 components of HVAC system works, right? Alright, so what you can see on your slides now is Jacob Perkins IMS machine. This is one of the first designed for aircon system, whereby you use ice and the refrigerant is ether or any volatile compound that evaporates at room temperature. So you can see here A is down there, water to be frozen. Let me bring in my pointer there. Okay, maybe just take this one out back. If I press it long, yeah, that's my pointer. A there is water to be frozen. So you have your volatile compounds here that evaporates as it accepts heat, and it will go to the B section, which is the evaporator, and then it will goes to a pump, C. Now this pump looks like a circular device where in the olden days they used animals such as horses and donkeys to turn this wheel round and round, so that we will have a circular motion of all these four components to cool down a room. In the olden days, maybe they used this to cool down some water, or maybe cool down a small room, right? And those who have the luxury to who can afford this machine will use this in their luxury homes during the summer. Right, the next page, also you have seen this before in your thermodynamics class, which is the psychrometric chart, where you have wet bulb temperature, dry bulb temperature, humidity ratio, relative humidity, enthalpy, and the volume cubic meter per kilogram of dry air. You have learned this, and we will use this extensively throughout our lecture series. Alright, let's go to the next component in our lecture today. So what is the difference between units and dimension? Units are specific, quantitative measure of a physical characteristic, and it's based on one standard. And standard that we use here in HVAC systems are ASHRAE standard of the American Society of Heating and Refrigeration. Alright, basically units are what we measure using components and equipment. Dimensions is the physical characteristics of what you are measuring, such as mass, length, time, force, and maybe coolness, and wet bulb, and dry bulb, so on and so forth, right? So the unit that we have for power and energy is kilowatt per second, right, or joule per second, and for energy is kilowatt per hour. So power here is the rate that of energy consumed, while the energy is energy used by the HVAC system per how long as you use it, and usually this is what is tariff by our government that you have to pay on the bill, on the tariff electricity bill. Right? Now, electrical power depends on the size of your system. Usually for split aircon, right? That one I have here in my room, and the one that you have in your room will be different than the one that we use in our campus, decentralized. So it is different on the capacity, load, and the demand that it is using, right? And energy used by HVAC&R depends not only on the size, but also the fraction of capacity loads that it operates. Sometimes you can operate at a full capacity. Sometimes you can have some saving if you operate at lower or a fraction of a full capacity. And also, how long do you run it? If you run it a longer period of time, then you have to pay more, of course. Now, on the next chapter is the unit that we use. You will use two systems or two metrics, which is the English system and also international system. Unfortunately, as the standard is governed by America, so technically most of your units will be that we will use is based on the English unit. At the first time, of course, you're going to be unfamiliar with this, but as we go along, we will have a lot of understanding on these units. It is just a matter of numbers. That's all. For example, for the US system, you will have gallon per minute, cubic for liquid volume flow rate, cubic feet per minute for air volume flow rate. So this one is liquid, this one is for air. You have inch water gauge for pressure measurement in airflow system. We have ton or 12,000 body temperature unit British temperature unit per hour. For the description of cooling capacity rate, ton hour is the cooling energy, feet per minute is for air velocity. Alright. BTU, not body temperature unit, but British thermal unit is a traditional unit of energy. Although this is under ASHRAE from the American, but they use British because technically the units are first used by the British. Alright, so 1 BTU is equal to 1055 joules. Energy needed to cool or heat 1 pound of water by 1 degrees of Fahrenheit. SI unit uses joules, but the English unit use BTU. The EER, energy rating efficiency, is the BTU rating over wattage. Higher energy efficiency rating equals to better efficiency and more cost saving, right? Right, let's go to sensible heat and latent heat. So throughout this class, you will be exposed to latent heat and sensible heat. Latent heat, what does it mean by that? More energy water when there is more water vapor in the air. That means as water is absorbed into a dry air, the air will become moist, wet. The more or the higher moist content inside air, the higher capacity of heat that it can absorb. So we call this as latent heat. Energy contained in water vapor as it is absorbed by dry air. So the dry air becomes a wet air, and how much heat can be contained inside the specific amount of air is called latent heat. Sensible heat is more about energy in air at higher temperature. It is addition to the heat raise the temperature. That means that, for example, the air is maybe at 20 degrees Celsius and increases to 26 degrees Celsius without the addition of water, for example, water vapor. So this is called sensible heat, right? And also enthalpy. You are familiar with this term as we have studied this in thermodynamics. Enthalpy is a total amount of energy for both sensible in the air and latent heat of the water vapor that is inside the dry air. So we call this enthalpy, how much energy that is contained in how much weight of air, right? So I believe the unit is kg, right? This is enthalpy and the symbol is an italic H. Right, let me clear it up. Okay, enthalpy can be raised. So if you want to absorb more air from the room, absorb more heat from the room, you have to increase your enthalpy absorbed. So how can we raise this? By adding energy to the mixture of dry air and water vapor, and also adding either both dry air and water vapor. So this is a trick that we use to increase enthalpy inside air. And you can use psychrometric chart to tell you how much energy is increased or how much enthalpy is increased by adding either dry air or by adding either water vapor or by adding both of them. So the psychrometric chart have this section. So you can see this is the dry bulb temperature down there, and this is the moist or the water content within the temperature given. So as you go along these lines, you are going to increase the enthalpy, right? And the enthalpy will be stated at this section, 10 kilojoule per kilogram, so on and so forth. Right, so we go to the next section. We're almost there at the end of the lecture, fundamental physical concept. So you have a few fundamental physical concepts that we will discuss one by one now. The first one is heating, cooling, then dehumidifying, then humidifying, then cleaning and ventilating, and air movement, and then finally control and instrumentations that you use in HVAC system and R. The first one, heating. Heating is defined as in a space condition, heating is performed either to bring heat from outside to inside. Let's say here you see a house in the winter. You can see that outside of the house is quite cold. The inside of the house is quite warm because you are there, and all the equipments and heat and fire inside the house, right? But you want to maintain heat inside your house, you need to bring heat from the cold place outside indoors. So this is a fit for HVAC system. Or in summer, you need to bring heat from indoors to outdoors. B, to replace energy being lost to colder surrounding by a space. That is the sort of meaning of heating in HVAC system. Second one is cooling. What is cooling? Cooling is a process of removing thermal energy from a conditioned space. So that is why when you want to cool down a room, we call this cooling. So sometimes we call it cooling load. Load such as in static, where a load is a pressure or a force acting on a surface, on a beam and so forth. Cooling load is the energy needed to cool down a space, right? So the purpose of cooling is lowering or maintaining the temperature of space to cool a space down. Dehumidifying is a process as literally it means by removing water vapor. So we spoke about latent heat just now. The more water content in a dry air of a room, the higher latent heat it will have, the higher enthalpy it will have. Therefore, a room that is have a high content of water will become humid. And as the room become humid, technically it will become warm and hot. That is why you always feel sweaty, even though in a cold room, as the room water content or moisture or humidity increases, right? To cool down yourself in a cold room, even you need to remove the water content from the air by the method of dehumidifying. How do we dehumidify a section of a room? We use a dehumidifier or a heating element that increase the water content, that it will become vapor and we can suck it out from the room. Alright, next, humidifying. If you can dehumidify a room to cool it down, you can also use humidifying to heat up a room without adding more heat. While a cold space, you can introduce hot air into the room. But again, heating element uses a lot of electricity. So you can also introduce water content in terms of air, moisture into a room, and as your body heat or the computer that you use or the lighting that you use inside the room have a heat, it will be absorbed by the moisture, and this heat will be contained inside the room, and the room will become hotter, if that is what you want inside that room. So HVAC system that also cool down a room. It can also heat up a room. It can also humidify the room and dehumidify the room. So while you move air around and surround it, you need to clean it. So to clean it, use a filter. So here it is famous. The most famous filter that we use is HEPA filter, which was developed during the World War II. It's very old. Some of the manufacturers uses a HEPA filter as a way to clean up a room. Next is ventilating. So you can ventilate the room naturally or using a mechanical ventilation using the HVAC system. Next is air movement. How do you control the air movement and circulation inside the room is important in HVAC system. Alright, some of the HVAC studies uses computational fluid dynamics or CFD to study how air is moved around and surround the room to cool down or to heat up the room, so on and so forth. Next is control and instrumentation. How do you control heat that is moved in and out, and how do you control that? To say the room is hot at 30 degrees Celsius, you want to cool down at 26 degrees Celsius and you want to maintain it. So you must have sensors and controllers and control devices to control the circulation of air around the room, surround the room, or a specific region of the floor. Let's say maybe level 1 of block C. Compared to your single room that you have there is quite different. So you must also learn about sensors, controls, and control devices. You will also learn about how to run this in full load and also part load. Next is done. Alright, so we have covered the introduction, unit, and dimension in HVAC system. And if you have questions, please don't be shy and text me on Times. I believe for the time being, we will use Times messages first, and once I have... So that will be our first week introduction, unit and dimension. I hope I managed to give an intro of what we are going to see this week. This semester. Sorry, I'm recording this at 12 a.m. So this is how we're going to work. This is how we're going to have our lectures and tutorials. I'm trying my best to do as much as I can that you guys can understand. Again, maybe I'm going to set up the WhatsApp group as long as this is going on, and also there's not much of you, maybe 16 or 17 of you in my class. Right, I'll see you on the next lecture, week 2. So bye.